Hello student, today I am going to explain you how to derive the equation of the volume of solids of revolution of the given curve. So suppose this is the y-axis and this is the x-axis, and suppose the given function is given y is equal to f of x. This is a given curve. Now when you plot this curve in the xy plane, suppose the curve looks like this. Then in this case, if we are to rotate it about the x-axis to get a solid, rotate it about the x-axis. That means you have to rotate this curve about the x-axis. For example, if I take this one as the x-axis and suppose this is the curve, then if I rotate it in this way, it will about the x-axis, then it will generate a solid. Now here in this case, after rotating this one about the x-axis, then you'll get this one figure like this, where the length height from here to here and from here to here will be the same. So suppose this is A. Let me mark this one. Between certain values of x, say from x is equal to A to x is equal to B, this is B. So the graph here will be like this, and then since it is a solid, so you see now that by rotating this curve about the x-axis, you'll get a figure like this. Now how to evaluate the volume of this one? Now for this, what you need to do is you cut, for example, if you take this bunch of this one and then cut this this solid here into this figure that is in the form of a disc, then you'll see that you'll get a figure like this one. A disc like this, where the radius of this one, let us take the radius of this disc to be y, because the length from here to here it present on the y-axis, so therefore let us take it as y. Now you see that we have to cut this solid in the form of a disc. Now that disc also must be, the thickness of that disc must be very small. Okay, so let me take the thickness of this one, that means from here to here as this one, since you see that it is parallel to this one, parallel to the x-axis, so let me take it as dx. So the thickness of this disc is equal to dx and the radius of this one is equal to r. So now you see that if you cut, in this way, this if you cut this body in this way into many discs, then in that case you can calculate the volume just by calculating the volume of that single disc, and then you'll be able to integrate it from x is equal to A to x is equal to B in order to get the volume of this whole solid here after revolving it about the x-axis. So now you see that I've taken here, suppose the radius of this disc is equal to y and the thickness of this disc is equal to dx. So you can see from this from here, since I've taken this one, the radius as r and the thickness of this one is equal to r, and we know that this one will this disc is a part of the cylinder only. That means when you cut a cylinder also, you'll get a shape like this one, which is in the form of a disc. Therefore we need to know now what will be the volume of the cylinder. As we all know that the volume of the cylinder is equal to pi r square into height, that is h, where h is the height of the this one of the cylinder. But in this case, since the height is very small, because it is very small here like this in this case, or if you see the disc also, the thickness of this one is very this, so instead of taking the height, we can take it as pi r square into the thickness. So this is the volume of the cylinder, so which means that this implies that the volume of the disc is equal to pi r square into the thickness. And what is the thickness? I've taken the thickness of this disc here that cut the solid here to be dx. You can cut this whole solid into different discs where the thickness of the disc is infinitely very small. So in this case it is pi r square into dx. But what is r here? The radius of the disc I've taken as y. So you'll get volume of the disc is equal to pi y square into dx. But since I have to calculate this whole volume from x is equal to a to x is equal to b, so therefore the required volume now is equal to integral x is equal to a to x is equal to b pi y square dx. So this will be the formula if the given function y is expressed in terms of x. So we have got the required volume of the solid of revolution will be equal to pi y square dx. Now, in case if the given equation is in terms of x is given in terms of y, that is, suppose x is equal to g of y, and for this case, if we rotate it about the y-axis, so if you rotate, suppose this is that curve represented by this pink color here. So now if you rotate it about the y-axis, the rotation here will be in this way, and in the first figure the rotation will be, because we rotate it about the x-axis, it will be in this way. So now if we rotate it about the y-axis, then the figure will be like this, where I've taken this point because we have to integrate from x is equal to c to x is equal to d. And again here you cut this, here it will look like a vase only. So now you cut this one solid into a small disc, into a disc where the thickness of the disc is very small. But since this one will be parallel to the y-axis, so I'm taking the thickness of this one as dy. And then let us take the length, the radius of this disc to be x. So in this case, the volume will be equal to the same thing like what we have done in the case of rotation about the x-axis. So volume will be equal to pi, instead of y squared, it will be x squared radius, then into dy the thickness from y is equal to c to y is equal to d. So this is how we are getting the formula for the volume of solid of revolution. When it rotates about the x-axis, it will be integral x is equal to a to x is equal to b pi y squared dx. And for when it rotates about the y-axis and x is given in terms of y, then the formula will be the volume of solid of revolution will be equal to integral y is equal to c to y is equal to d pi x squared dy. Hope it is clear now how we can derive the equation of the volume of solids of revolution about the x-axis and the y-axis. In the next video, I'm going to explain to you how to find out the formula or derive the formula of the surface area of the solids of revolution.